when building a robot, then it's very important to choose the right motor. We decided to use servo motors since they are quite inexpensive and they are very easy to use. You can directly connect servos to an Arduino board, microcontroller of almost any kind, Raspberry Pi, and so on. So it's actually really ideal, except for one fact, that servos usually do not allow continuous rotation. But now we are going to discuss how you can turn a standard servo into a continuous rotation servo. If you don't like modifying a servo yourself, you can also buy some continuous rotation servos, but they are not so common, so it might be cheaper and easier to do it yourself. So before we start, I'd like to show the differences between the normal servo and the continuous rotation servo. So this is the normal one, and this is the modified one. Here you can see that this one here supports continuous rotation, which is very nice for driving a robot. And since okay, so now let's start. Now first I have to disconnect them. Okay, I take away this one here because it's already modified, and we continue with this one. So this procedure may vary between servos, but it's essentially the same procedure. So there might be some minor differences, but I think it's very easy to apply that to a different model. Okay, so I have prepared some tools here. We have some screwdriver bits and a knife that we will use later. So we start by unscrewing the servo here. Okay, so we use the screwdriver to okay, so now we opened the servo. Looks like this. So we use a different bit. I need a smaller one. Okay, we should be able to remove this part here as well, but be careful because we don't want to lose all these gears. Okay. This one should fit in here. And don't be afraid if your servo looks a bit different. It's essentially the same procedure for all models. Okay, so here are two additional screws we have to remove. And what we are trying to do is to stop this resistor from rotating, because this is how the servo can detect whether it reached its position. And this is what prevents the servo from rotating, because also this resistor does not support continuous rotation. And this is why we have to push it down here. So it is not connected to the gears anymore. And the cool thing is that what we do here is actually reversible. So if you decide to use your servo as normal servo later, then you should be able to do that by just pushing the resistor up again. So, but before we can do that, we have to open the servo. So be careful to not damage the electronics. Okay. And here you see that we have this resistor here, and we can easily take it out by pushing these parts just out of the way. And we push with our finger here, and then we use the screwdriver to push this apart here. Yeah. Now we have it. That was easy. You see, we pushed the resistor down, and we should be able to use the servo as expected now. We just have to reassemble it. And there might be one additional thing that actually prevents continuous rotation. It prevents the servo from rotating freely. And it is very important, because usually when you use a servo in a car or plane or something like that, then you could have external forces that are stronger than the servo, and rotating freely could destroy this resistor here. And that's why we have this part here for protection. And actually we have to remove it now. Some models don't have this additional protection, so you can just push the resistor down and use it. But in our case, we have to do that. We have to remove that. And yeah, we just use this knife here. You might have a better tool for doing that. But it's very soft plastic, so it's not difficult at all. Okay, so now we are done. That should be enough. Okay, so now let's reassemble it, and let's try it out. So now comes a very important part. We are going to calibrate the servo, and we attach it to the Arduino, and this program that you see here tells the servo to go to the 90-degree position. And then we are going to move this resistor till the servo does not move anymore. Okay, and then for degrees lower than 90 it will move into one direction, and for bigger than 90 it will move into the other direction, and then it will get faster the farther it gets away from this 90 degree. And the biggest value is 180 degrees, and the lowest value is 0 degree. Then we have essentially a motor where we can not only control the direction but also speed. Therefore it's very important to do a precise calibration. Okay. Okay, now the servo moves quite fast, and we change the resistor position, Okay. Now we are almost there. It actually has to stop. Okay. It almost stopped. Yeah, now it stopped completely. I think this is the closest we can get. Yeah. This should be okay. Maybe. Okay, now we reassemble the servo. So now we reassemble the servo. Okay. Okay, that's it. Also das wird es auf jeden Fall. So that's it. We reassembled the servo. It looks exactly like before, but we can use it as motor device. Using two of them will allow us to build a very nice robot that can freely move. Yeah, so that's it.